Hello again. Uh, so once again, this is Mary Jade Jakosalem, currently a student enrolled at AMA Online University. And for this video, I will be doing at the same time discussing the laboratory exercise number 3 for the subject ITE 7104. So for this laboratory exercise, we are going to do the configuration of IP addresses and subnet mask onto the host. So to start with, let me open the instructions given. So this is the instruction. So of course, as seen from my previous videos, I already installed the Cisco Packet Tracer. So instructions here, I need to open the Cisco Packet Tracer. So let me open it. And then I need to connect 4 PC, 1 hub, and 1 switch. And then I have to click once on PC0 just shown in the figure below. This is our Cisco Packet Tracer. So let me add 4 PCs. Okay. And then I need 1 switch and 1 hub. Okay. And then going back to the instructions, I need to choose the config tab, and I can change the name of PC0, but I will let it remain as it is, PC0. I can also enter the gateway IP address, also known as a default gateway. After that, I need to enter the IP address 192.168.1.1. So let me do it. Okay, so let's go to the config. And the default gateway is 192.168.1. And then I need to click on the fast internet, and I also have to enter the IP address 192.168.1.1. So let me copy paste it. And then as you can see here, there is the default subnet mask. So it's automatically displayed. The default subnet mask is automatically displayed below once I entered the IP address. And then let's close this one. I have to repeat these steps for the other end devices, specifically for PC0, 1, 2, and 3. So I have to set the following IP address. 192.168.1.10 for PC0, 0.20 for PC1, so on and so forth. So I will do it now. Okay, let me full screen. So I need to change this one to 10 because that was what was stated on the instructions. Okay, and then close. And then this one, this is gonna be 20 because this is PC1. And let me copy paste that one. And as you can see, the subnet mask is automatically there. Then this one is going to be 0.30. Then right here is also 0.30, and you can also see the subnet mask. And the last one is going to be 0.40. And again, the subnet mask. So we are done with the instructions 1, 2, 4. So we're all good. PC0 is set now. The IP address is now set to 192.168.10, and then PC1 is 192.168.1.20. PC2 is 192.168.1.30, and PC3 is set to 192.168.1.40. So I need now to connect PC0 and PC1 to hub 0, and then PC2 and PC3 to switch 0. I believe this is switch 0. And then I need to connect the hub 0 to switch 0. So I need to connect this, and this. So the connection is okay if a green light appears for every connection. So let's do it now. So I will just use here the automatically choose connection type so that it will be easier for us. Okay, so we're all good. All lights are green. Okay, but we have a 1 amber light, but I believe it will change to green soon. And eventually, so I believe we're all done. We have connected PC0, PC0, PC1 to hub 0, PC2 and PC3 is connected now to switch 0, and hub 0 is connected to switch 0. However, we still have some amber lights, so I believe it's still not in the forwarding stage, so we need to wait. Okay, now PC2, PC3, all green lights. Okay, now all are green lights, so I believe we can proceed with the next instruction. So I need to simulate the networks by switching the real mode to simulation mode. So right here, we are right now in the real-time mode. So I will now switch this one to simulation mode. Okay. And then, after switching to simulation mode, I need to click, and this is the envelope right here. And I have to drag it to either one of the PC and click another envelope and drag it again to another PC and click the auto capture or play button. And then I need to observe the flow of messages and determine its status if it's successful or failed. So right here we have the envelope. So I will put it to the PC0, and then I will put another one to PC2. And then we have here the play button. So we have two play buttons. So either one will do. So we are now starting our simulation. This is what you can see. I actually fast forwarded. This is too fast. So this is what you can see. If it is successful, the envelope is in green, but right now it's not yet in green. Yes, so there is a check button as well. So it shows that it is successful. So the transfer to PC0 is successful. However, for PC1, it's not, since PC2 and PC3 as well, since there are X buttons. So right now, it's all X. So here we have successful as our status. Also X. But in the first simulation, we had the one successful. So we could perhaps try to reset our network and then try to play it again. But right now, our connections is not good. So I paused the simulation. So that is right here. Okay, so I believe the configuration, it's all intact. So that's it for our simulation. I will now be answering the questions here. So what is the first question is, what is the importance of gateway? So first, let me define what a gateway is. So basically, in the context of networking, gateways, gateways serve as an entry and exit point for a network. So this is where data enters or exits. It is designed to translate different protocols To translate, or rather, to translate traffic between different protocols. So these translations enable networks using different protocols or data formats between with a network gateway performing inline translations. Okay, so first of all, what is the importance of a gateway? So basically, in the context of networking, gateways serve as an entry and exit point for network. This is where the data enters and exits. So it is designed to actually translate traffic between protocols. So as you all know, there are different protocols, and gateways actually translate traffic in different protocols. So basically, this translation enables networks using different protocols. Even if you are using various protocols, you can still be linked together because of gateways. Because the gateways are the ones that performs the translations. So hence, gateways are very important. So what is the transmission medium used to connect the hub and switch? So it was the copper crossover cable. So just to be sure, let us double check. So here we have from hub to switch. So what you can see here, it's clearly a copper crossover cable. And then what is the indication if the connection of your PCs are successful? So as what we can see, all lights are green, and if there are no amber lights, all lights are green. So it means that it is successful, the connection is established, and when you press the play button in the simulation mode, the envelopes, there is a check on the green envelopes, signaling the success of data transmission. So basically, if connection is successful, all lights are green, and when we are in a simulation mode, when we click play, there is a check on the green envelope signaling the success of data transmission. Furthermore, no excess can be found, because if there is an X, meaning it's not successful. So as what you saw in our video, when we started the simulation, if there is X, it's not successful. So what can I conclude from this activity? In conclusion, gateways are essential in networking. In conclusion, gateways are essential in network because, as what is explained above, it translates traffic between different protocols, and each end device should have a unique IP address. Each end device should have a unique IP address for a successful connection. Furthermore, when you enter a specific IP address, the subnet mask is automatically generated. So I guess that's it for this activity on configuration of IP addresses and subnet mask onto the host. So again, as conclusion, gateways are very essential in networking because they are the ones that would enable the transfer of data regardless of different file types or different protocols. So it helps the transfer of data in a network. Furthermore, each end device should have a unique IP address for a successful connection. And then when you generate a specific IP address, the subnet mask is also generated. So thank you so much and God bless.